He who here from LeetCode. Today we're solving LeetCode 238, product of array except self. This is a medium difficulty problem, and it's one of the most important array problems in the LeetCode 75 study plan. At first glance, it sounds pretty simple. For every position, we need the product of all the other numbers. But there's one restriction, and that restriction changes everything. Let's take a look. Here's what the problem says. We're given an integer array. And for every position, we need to return the product of all the elements except the current one. Sounds straightforward. But there's an important condition. We're not allowed to use division. That immediately removes the most obvious solution. Because otherwise we could multiply all numbers once, and divide by the current element. But the problem doesn't allow that. And then there's the follow-up. Can we solve it using constant extra space? So we're not just looking for a correct solution. We're looking for an efficient one as well. Now that we understand the challenge, let's see exactly what the problem is asking us to compute. Let's focus on the first example. The input is 1, 2, 3, 4 for index 0, we ignore the 1. 2 into 3 into 4 equals 24 for index 1, we ignore the 2. 1 into 3 into 4 equals 12 for index 2, we ignore the 3. 1 into 2 into 4 equals 8 for index 3. We ignore the 4. 1 into 2 into 3 equals 6, so the final answer becomes 24, 12, 8, 6. Notice something important. Each answer depends on every element except itself, and we need to calculate that for every position, without using division. So how would we do that? Let's start with the most straightforward approach. Suppose we're calculating the answer for index 0. We simply multiply all the other elements. Then we repeat the same process for index 1, then index 2, then index 3. In other words, for every position, we scan the entire array again. It works, it's simple, and it's usually the first idea most people think of. Now let's see how we can implement that idea. We'll start by creating our answer array. Then we'll iterate through every index. For each position, we'll initialize a product variable to 1. Next, a second loop visits every element. If we're looking at the same index, we skip it. Otherwise, we multiply the value into our running product. After finishing the inner loop, we store the product in the answer array. Then we move to the next position, and once we've processed every index, we return the result. Simple and easy to understand. But let's see it in action. Input 1, 2, 3, 4 for index 0. 2, 24 for index fun 1 into 3 into 4 result 12 for index 21 into 2 into 4 result 8 for index 31 into 2 into 3 result 6. Final answer 24, 12, 8, 6. The logic works perfectly. But notice something. We're repeatedly multiplying the same numbers. The value 1 gets used again and again. The value 2 gets used again and again. And the same happens for every element. We're doing a lot of repeated work. Can we somehow reuse those calculations? Let's analyze the complexity for every element. That gives us O of n squared time complexity. Space complexity is O of 1 excluding the output array. The solution works. But O of n squared is expensive. Before jumping into a better solution, let's look for a pattern. Take index 2. Its answer is 1 into 2 into 4. Notice something. This product can be split into two parts. Everything on the left, and everything on the right. For this example, left product 1 into 2, right product 4, and the answer becomes left product into right product. Let's test the same idea for index 1. Left product 1, right product 3 into 4 again. Answer equals left product into right product. Interesting. This idea should feel familiar. It's very similar to prefix sum. In prefix sum we store running sums. Here instead of sums we store running products. You can think of this as a prefix product pattern. And once we know the product on the left, and the product on the right, we can calculate the answer immediately. Now let's use that idea to build an efficient solution. We know every answer needs left product. Multiplied by right product. One option would be storing all left products. But that would require extra arrays. Can we avoid that? Yes. We can store the left products directly inside the answer array. Then during a second pass, we maintain a running right product, and multiply it into the answer. This allows us to compute both sides, without needing extra helper arrays. Let's translate that into code. We'll start by creating the answer array. The first position is initialized to 1, because there are no elements to its left. Now we move from left to right. At every index, we store the product of everything before it. By the end of this pass, the answer array contains all the left products. Next, we move from right to left. We'll maintain a variable called suffix. Initially, it's set to 1. For every index, we multiply the current answer value by suffix. This gives us left product into right product. Then we update suffix using the current number. and continue moving left. By the time the loop finishes, every position contains the correct answer. Input 1 2 3 4 first pass. Answer becomes 1 1 2 6. Now we start the second pass. Suffix begins as C1 index 36 into 1 equals 6. Update suffix 1 into 4 equals 4 index 2 9. 8 update suffix 4 into 3 to 12 index fun 1 to 12 tasbuff leflu update suffix 12 into 2 equals 24 index zole 1 into 24 equals 24. Final answer 24 28. 6 exactly what we wanted. Let's analyze the complexity. We make one pass from left to right, and one pass from right to left. So the time complexity is O of n. What about space? We're using the answer array itself, and only one extra variable, so the extra space complexity is O of 1 excluding the output array. And that's exactly the follow-up solution the problem is looking for. Let's quickly recap the key idea. For every position we need left product multiplied by right product. Instead of calculating those products repeatedly, we build the left products during the first pass and store them directly in the answer array. Then during the second pass we maintain a running right product and multiply it into each position. This gives us the final answer in just 2 passes. Time complexity O of n space complexity, O of 1 excluding the output array. And that's the main takeaway from this problem. When an answer depends on everything to the left and everything to the right, think about prefix products and suffix products, and that's how we solve LeetCode 238, product of array except self. If you found this explanation helpful, make sure to like the video and subscribe to LeetCode. Thanks for watching. This is Hugh signing off. Keep practicing, and I'll see you in the next one.